Question number 1 asks us to find the x-intercept and y-intercept for the equation to the left and to use those to graph it. Decimal answers are okay, we're going to see those show up, so don't worry about that. All right, the way I would like you to start this is to use our observation in class that we said that there are zeros for the x-intercept and the y-intercept. I need to see those zeros in order to give you a full grade on this. Now that 0 is in the y position, that's the y variable for our x-intercept. So at this point we're going to use our equation, 5x minus 3, but we're going to replace that y value. That y value is 0, so we're going to put that in there. Again, I need to see that 0. 3 times 0 is 0, so we end up with 5x and a 0. That leaves us with just 5x, because that 0 doesn't make a difference. So we have 5x equals 27. Finish this out by dividing by 5. And we end up with x equals 5.4, or you could leave it in fraction form if you wish. So 5.4 is our x value. Over here for the y-intercept, we have our x value is 0, so we have 5, and we're going to replace that x with 0. Minus 3y equals 27. All right, 5 times 0 is 0, so that goes away. We're left with negative 3y equals 27. Solving this, we're going to divide by negative 3, divide both sides by negative 3, and that leaves us with y equals negative 9. So that's our missing y value there, negative 9. All right, erase this, give me some space here. Please leave your calculations shown when you do the test. Our last part of this is to take these two values and graph them. So 5.4 and 0 would be in between 5 and 6 on our x-axis, so right about there. And then 0, negative 9 would be down here at negative 9 on our y-axis, and we finish that up by drawing a line between those 2 points. And that's the end of that question. Next one asks us to do the same task, so we're going to use our zeros again, like we did before. X-intercept has a y value of 0. Our y-intercept has an x value of 0, and we're going to find the missing values. So this gives us negative 2x plus 8, and we're going to replace that y value with a 0. That equals negative 40. All right, 8 times 0 is just 0, so that leaves us with negative 2x equals negative 40. Over on this other side, we're going to replace the x value with 0. So we get negative 2 times 0 plus 8y equals negative 40. All right, got to finish this one over here on the left. Didn't quite do it. So we're going to finish this one down by dividing by negative 2 on both sides. And that gives us x equals positive 20. And that is our missing x value right there. All right, on this side we get negative 2 times 0 is 0, so that leaves us with 8y equals negative 40. Finish this out by dividing by 8. Divide this side by 8, and we get y equals negative 5. That's our missing y value right there. Now on this one, I gave you a graph that wasn't quite big enough to fit that 20 for our x-intercept. So for this one, we will need to add some space to the right-hand side. So I'm going to scooch this over, give myself some space on that right-hand side. We go to 10, so we're going to go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Put that 20 all the way over there. And then 0, negative 5 for our y-intercept. 0, negative 5 right there. And we draw a line. Let's undo that and make a better job. Draw a line through those 2 points. All right, rulers would be super helpful right there. Okay, next, our task is to find the slope of this line. This very first one is a vertical line. The slope for every vertical line is undefined. So when we do our rise, we get some value, and then our run is 0, but we cannot divide by 0. So that division right there makes it so our slope is undefined. Anytime we see a vertical line will be that case. Moving to the next one. This one we do have a slope, so we're going to use rise over run to organize that. we're going to go down and to the right. This would also work if you went up and to the left. Just make sure to keep careful track of your positives and negatives. So when we count how far we go down, it's 1, 2, and since we went down, that would be -2. And then we go over 1, 2, 3 spaces. It's a +3 because we went to the right. So our rise will be -2, that's the up and down. Our run will be +3. That cannot be simplified, so we're going to leave this as -2/3 for our slope. If you went up and to the left, you would have ended up with +2 and -3. Still would have gotten you -2/3, so either direction will work. Next question. We have a horizontal line. Now there is no rise. It doesn't go up, it doesn't go down, so our value for our rise is 0. And if we take 0 and divide it by any number, we end up with 0. So horizontal lines always have a slope of 0. Every single horizontal line has a slope of 0. Next question. All right, this one we do have a step right here, a rise and a run. So we're going to organize that again by rise over run. All right, the rise on this one is 1, 2, 3, 4, 5, 6. That would be +6 because we went up and we went to the right 1. So that would be +1 because we went to the right. So our slope would be 6 over 1. You can write that as 6 over 1. 6 divided by 1 is equal to 6. So you could just write it as 6. Either one of these two would be acceptable. All right, this one, we could use our strategy, take these values and graph them, but these are fairly large negative values, and I don't really feel like graphing all of those. So we are going to use a different strategy on this one without graphing it. Now our slope still is going to be rise over run, and the rise is the y direction. We're going up and down. So if we take a look at the change between each of these, we end up going down by 4, down by 4, and down by 4. So we can see that rise showing up in the change of those values for the y variable. The run will be x. So if we take a look at these x values and see how far they're going over, we can see that this goes up by 2, up by 2, up by 2, and that would give us our run for the slope. So rise over run will be -4 for the rise, and +2 for the run. That can be simplified. 2 goes into both of those. So we could write this as 2 over 1, and it will be negative because positive, or negative divided by positive. Or we could just write that as -2 because -2 over 1 equals -2. Either one would be fine. Or -4 divided by 2 is also -2. Moving on to the next example, we're going to use the same strategy. So our y values are changing. Each of these is going up by a value of 12. Our x values are changing as well in a consistent pattern. This one we are increasing by a value of 3 for each of those. So we have our rise. Again, rise is the y variable because we're going up and down. We have our run, and again, the run is the x, the change in the x because we're going left and right. So our rise over run would be 12 over 3. 12 divides nicely by 3, so you could write that as 4. Or again, if you like it in fraction form, that would be 4 over 1. Next question. Same strategy, and again, these are very large values, so I think I wouldn't really want to draw this graph by hand, but if you wish, you can always do so. So our y values are changing. That'll give us our rise. These are each going down by 4. Our x values are changing in a consistent pattern. These are each going down by 6. So organizing this, rise would be -4. The run would be the -6. 2 goes into both of those values, so I'm going to simplify this. 2 goes into 4 twice. 2 goes into 6 3 times. And we have a negative divided by negative would make our overall number positive. And that doesn't simplify any further, so we're going to leave it as 2/3. Next question. This one, we can see that our y value stays the same. It would be +0. So if we were to graph this, we would see that because the y value stays the same the whole time, this is a horizontal line. But putting this in terms of rise over run, 11 to 16 would be 5. So we know that horizontal lines have a slope of 0, and we can see that in the calculation where we say our rise, 0, over our run. 5. 0 divided by 5 gets 0, and that again confirms that this is a horizontal line. Next question. All right, our task is to graph this one, but we're going to use the slope and the y-intercept this time to graph it. So, refreshing our memory about slope-intercept form, we have y equals mx plus b. M is our slope, b is our y-intercept. So we can see the value for m is -2 in this one. It's right there, attached to the x. And our value for b is -1. It's right there over here at the end. So our slope is going to be -2, which I will write as -2 over 1, because we're going to use it in fraction form for our graph. And our y-intercept is -1, which I will write not in fraction form, because we can just put that right there on the y-axis. So your y value is -1. Our slope, -2 over 1, tells us we're going to go down 2 and to the right 1. So from here we go down 2 and to the right 1, down 2 and to the right 1, and that'll give us a couple extra points right there. And we also want to go the other direction, so I'm going to reverse this by going left 1 and up 2, and left 1 and up 2, and we'll draw a line through there. So here is our graph, and again, a ruler would be super helpful on this one. All right, next we can see our slope right here. Slope is -3/2. Write that right there. Our y-intercept right there is 1, and it is positive this time. So +1 on our y-axis is where we're going to start with our y-intercept. Our slope being negative tells us we're going to go down 3 and to the right 2. So if I do that, go down 3 to the right 2, down 3 to the right 2, will give me another point and another point. Reversing that would go to the left 2 and up 3. So we could go both directions. Finish that out by drawing our line through all those points. Next question. This one is a graph of a horizontal line. Remember, if our y value needs to stay at 3, we're going to look like this. Our slope is 0 for horizontal lines, and our y-intercept is right there. It's just 3, because all of our y values are 3. Moving on to the next, we have x equals -4. So if our x value is -4, and we want to stay at an x value of -4, we're going to have a vertical line here. All right, slope of vertical lines is undefined. We saw that earlier in the practice test. And our y-intercept is a little bit tricky on this one if you're not familiar with vertical lines, but thinking about this will never cross the y-axis because it's going straight up and down, so there is no y-intercept. So I'm just going to write none for something that means the same thing. Do not write 0 here, because 0 would mean our y-intercept is right there on the y-axis at a value of 0, and that is not the case. Next question. All right, this one, we do not have it in slope-intercept form of y equals mx plus b, so we need to do a little bit of rearranging before we get there. To keep our goal in mind right here, we're trying to get the y by itself, and so we've got to solve for that variable right here, the y. All right. So let's get rid of this x first. We're going to do so by adding x on both sides. Add x to that side. That would give us 2y. And I'm going to write the x term first, making sure it's positive. That would be x plus 10. Now a 1 will be useful, so that x is 1x, and that's going to come in handy when I do the next step. So we're going to divide by 2 here to get rid of that 2. Both of these need to be divided by 2, and this is where that 1 comes in handy, because we can see our fraction is 1/2 now. So I'm going to write 1/2 x plus, and then 10 divided by 2 is 5. So there is our slope-intercept form. We can see y equals mx plus b. So that's what we're going to write down here in the space for equation. So stick that right there. And then we have our slope and our y-intercept. Now we can graph this. Our y-intercept is 5. So I'm going to put that there. Our slope is 1/2, so we're going up 1 and to the right 2. And we've run out of space, so I'm going to go the other direction. We're going to go left 2 and down 1, left 2 and down 1, left 2 and down 1. Get a few points right there. Draw a line through all those, and we are finished with this question. Next one we see is also not arranged correctly. So we're going to rearrange it to be slope-intercept form, y equals mx plus b. So we need to get that y by itself. We're going to start by subtracting that 4x, get rid of the x term, subtract 4x on this side. So that would give us y, and make sure that this time the y is negative. That subtraction means it's going to be negative when we're done with that step. Over on the other side, keeping the x term first, we have negative 4x. Again, seeing that minus right there would make it a negative. And then the 8 is also negative because it started that way right here. Right, let me clean up this side a bit. Next step, we need to deal with this y, keeping in mind that there is a 1 there. Shows us that we can do so by dividing by -1. Divide both of these by -1, and we get y equals negative divided by negative will be positive 4 over 1x. You could write that as 4x, but I'm going to keep it as a fraction because of my slope. And then -8 divided by -1 is positive 8. All right, we'll need to stretch this graph out just a little bit again. So positive 8 would be up here, and 4 over 1 is going to take us off the graph this way. So instead of going up 4 and to the right 1, which would put me up here, I'm going to go to the left 1 and down 4, and then to the left 1, down 4, and we're going to find those values there. So that would show us the line and get us into a place where we have some space to work. All right, just a few questions left here. So this story problem right here says you're going to the school carnival. You have $24 to spend on food and games. We can buy food tickets for $4 each. We can buy game tickets for $2 each. This equation shows us how we can use our money to, or use those tickets to come up with the $24 and use it up. X is the food tickets and Y is the number of game tickets, and so the graph is going to show us our possible combinations of food and game tickets. Now this one I would like to go back to what we did at the beginning. I'm going to use my X and Y intercepts because it's in standard form. I kind of like that. So my X-intercept will have a Y value of 0. Yay! If you want to solve this for slope-intercept form, that is fine. You can graph it that way as well. So this one is your choice. All right, we're going to use that 0. So we have 4x plus 2 times 0 equals 24. 2 times 0 is 0, so that leaves us with 4x equals 24. Finishing this out by dividing by 4, we get x equals 6. So that's our missing value. 6, 0 happened right there. All right, I'm out of space. Please do not erase your work, but I am out of space, so I need to do so. All right, let's find our y-intercept. So our y-intercept, we know our x value is 0. So I'm going to put that in. We get 4 times 0 plus 2y equals 24. 4 times 0 is 0, so that leaves us with 2y equals 24. Finishing this out by dividing by 2, our y value equals 12. So that's our missing y value, and that would be way up here at the top of the graph. Okay, connecting those two now with a line will show us our possible situations. Now again, you could have put this in slope-intercept form, y equals mx plus b, and that would have given you the same graph overall. And I do not care which way you do it. All right, our next question asks us to find 4 possible solutions. We've actually already done 2 with our x and y intercept. So this right here, 0, 12, tells us there are 0 for the x, which is our food tickets. That would be 0 food tickets and 12 game tickets, because that's our y value. So 0 food tickets and 12 game tickets is our first possible way to spend that $24. Down here at the x-intercept, that was 6, 0, so that was 6 food tickets and 0 game tickets. So 6 food tickets and 0 game tickets. Now the graph is supposed to help us identify the other solutions right here. And so if I take a look at the graph, I'm looking for some nice corner places that give me some alternate possibilities, and this one's a good one right here at 2 and 8. Now, my graph's a little bit off, so a ruler would have been super helpful. It was supposed to go through that point. So please be very careful to draw this and be accurate. There we go. All right, so 2, 8 is one of the locations on my graph. That would have been 2 food tickets and 8 game tickets. And then another possible solution is 4 and 4. So 4 and 4, and now that I got that graph a little bit straighter, you can see that that fits right there on that line. And so that would be 4 food tickets and 4 game tickets. Those are 4 different possible ways to spend that total of $24. Moving on to our last 2 questions here. All right, so here we go. We've got an equation right here. It says this represents the cost, which is why they use the variable c, of renting a chainsaw from the local hardware store. X is the number of hours you rent the tool. So we are asked a question, how much is it going to cost if we rent the tool for 3 hours? So that 3 hours says, hey, we've got a value for that X. So we're going to plug that into our equation and calculate the cost. All right, that's going to look like this. So since our X value is 3 for that 3 hours, we're going to have C of 3 equals 4.75 times 3 plus 18. 4.75 times 3 is 14.25. You are welcome to use a calculator on that if you need to. So we get plus 18 again. 14.25 plus 18 is 32.25. So our cost is $32.25 for that. All right, now the next question says, what if we do it for 7 hours? It's the exact same strategy. We're going to plug in a 7, though, this time for our X. So we have 4.75 times 7 plus 8. 4.75 times 7 is 33.25. 33.25 plus 18 right there. 33.25 plus the 18 is 51.25. So that would be $51.25 this time for the 7 hours. And we are finished with that. Good luck on the practice quiz and the quiz. Thank you very much.